Good morning, friends. In the previous video, we discussed about the features-based OMS, in which we used commutable features to create the OMS and do the order handling part. So let's revise it quickly. So we had created a thread pool of four threads for connection handling, which means that four simultaneous client connections can be done, and there were 12 threads for order handling pool. So if you look at the handler part, so only 1 second was taken to create this request object because we have mimicked it to create 1 seconds from the socket. And after that, we actually wrapped all this validation part, enrichment, and persistence part into three completable features: supply async, and all of these completable features, they were not using order object as such. So this order object is not required yet. As you can see that we are using the request object directly. It means that this is not required. And once we run all this program, we saw that the whole process, including this creation of the new order object, as well as all these three parts, can be done in parallel. So that's why uh, taking 1 second here and 1 second here concurrently, and the third second here to send the order to downstream. So it total took 3 seconds. Earlier it was taking 4 seconds because our validation and enrichment and persistence part was done after the new order was created. So here we have parallelized this, and that's why it was much better. The only problem that we saw is that the use of the join method, as this join method is a source of like a lot of issues like deadlock issues, and if one of the requests takes longer time than expected, then it will impact the whole parallelism of all these four steps that we are doing here. So to avoid all this, in the next approach, we will see that how to uh, avoid this join method call by using callback methods. So futures with callback OMS means that this is one of the oldest strategies, and the idea is that instead of waiting or blocking for the future results to come back, we can specify a callback that whenever the computation is complete, a callback is called, and the result can be used thereafter. So instead of using all these joint calls here, this can be replaced by the callback methods. And the callback method that we are going to use is thenAccept. So thenAccept is the way that we can register all these features to have a callback whenever the actual implementation is being done. So for example, in this one, we have created all these features as before. So we have got supply async. All these features are created. Okay, and after that, we have created this callback that whenever the validation is done, the final object that we get after validation, it will accept it for further operation for order enrichment. Similarly, for order, once order enrichment is completed, only then it is going to accept or the callback method to enrich the order. And finally, it will persist and send it to the downstream. So even though all this is done, so just have a very clear mind that whenever we are registering any feature with a then accept method, it is not invoked at the same time. It is something which is to be done later when the actual operation is done. For example, if this persistence is done, only then this then accept will be called. So this is a way. This is the way that how we actually can delegate all these results of the future without joining them or waiting for them, and just using the results when it is actually completed, and use that result for the further operations that we have built in this callback method. In this case, the callback is then accept. So in theory, it is again going to take 3 seconds as before. So in the future-based OMS, here we saw that all this is done without the order object. So that's why it was 1 second for this. And all these four operations, like creating the new order and validation, enrichment, persistence, all took 1 second in parallel. And this send to downstream took more like 1 second. In a similar way, here, if we just calculate theoretically, this is going to take 1 second. This is going to take 1 second again. And after that, all this operation, because this is of the callback, this is the beauty of the callback, that all this operation could be done in parallel, and it would be taking only 1 second each. So it means that it would be total 3 seconds again. So this is our theoretical understanding. And as mentioned that the then accept methods only registers this code for later execution. It does not wait for the feature to be completed, and thus it takes very little time. And the actual build of object building will run later in the thread pool after the validation, enrichment, and persistence tasks are done. So what it means is that whenever this validation enrichment is done, because of this callback message that we are calling thenAccept method, only then the order building will be done in parallel in the thread pool and sent to the downstreams at the same time. That's why I mentioned that it is going to take 1 second, which is done parallelly. And it would be the maximum. I mean, we have already mimicked that all these 3 steps take 1 second each. So it would be max of 1. So it's if it is like one of the enrichment takes like more than 1 second, then it would be the max of it. But the idea is that all these 3 steps would be done in parallel along with the order building. And that's why it will take only 1 second. And in this case, in this scenario, there would be no risk of deadlocks. In the previous version, when we are using join, in that case, although we have like segregated the order handling part and the connection handling in separate pools, but still there was a caveat there for having there might be some scenario there where we can have the deadlocks. But using this approach, that the deadlock can never happen, because and even if we use only like one thread in a single in our thread pool, for example, in our code here, if I change this order handling pool to only one thread, so here it is, we are just going to use okay, so I'm already using only like fixed thread pool of 12. We are not having a separate type of connection handling pool, because in our previous version we were using separate pools for connection handling and order handling because we were using join. And that was actually a caveat. If you are using the same thread pool for both order handling and connection handling, that could result in the deadlock. But after using the callback message like thenAccept methods, we don't need separate pools. We can use just single thread pool of 12 threads for both order handling as well as for connection handling as well. So that's why this is like deadlock free. We can use the same pool, and it is going to take the same 1 second each. For example, 1 second for new request, 1 second for creating the order, and finally, it will do all the steps in 1 second. So being said that it takes 3 seconds, let's run it and see. So I will just run this feature with callback OMS. So it will listen on 8080 port as expected. We have got a thread of 12 pools, and we are going to just run a socket client of 4 simultaneous connections, which I have created before. Socket client 4. So I just run this. So we expect that each of the 4 client connections should be served by this server in 3 seconds each. Let's see. So it's already connected and disconnected now. Let's see here. So okay, I see that one of them even took like 2 seconds, around 2 seconds, 2 seconds each, 2 seconds each, 2 seconds each. So it's like so fast that what I'm observing is that this took 1 second and this took 1 second. But because this is like done like by 12 threads at the same time, so what I assume is that the whole operation of this one, it was done so fast and like in a concurrent way, that the way that it wanted to create this order object and the way it was handled here when it was in the callback message, when it was creating the order object after validation, enrichment, and persistence, it was too fast that even though this three process, validation, enrichment, it took like 1 second each, the remaining part to build the order and send it to downstreams, it took less than even 1 second. This is evident from the output. So this is only taking like little bit more time. So I would say that it took only like 117 milliseconds or like 20 milliseconds for this step for creating the order object and send it to downstream. So it was that fast. So this is the beauty. I would say that first of all, we have removed all those problems that was there, that we had to maintain 2 separate pools in our previous features-based OMS, in which we were using the join method calls. Because there was a possibility of deadlock, that's why we have to use 2 handlers, one for connection handling and another for order handling. So there are threads available for both separate parts. But for using the callbacks, first of all, we actually removed that deadlock scenarios because we are using just the callback. And we also found that it took like even less than 3 seconds. Theoretically, we are thinking about it will take 3 seconds, but because this is such a simple method and we have got enough threads available, so I think it was too fast that even creation of the order and doing all these 3 steps also almost ran in parallel, and it took around 2 point something seconds. So so we have gone through all this. I think this is a much better approach than the previous one. And also there is no need of any synchronization here because this is all callback. We can also run it with a single thread. It will give almost the same performance. But the only caveat is there. You can see the code here. It is 3 levels down deep. I mean, if we just talk about the clean code and all those stuff, the code is looking very complex. If I try to like debug it, or if I want to like go through the code, so this is the only caveat I can see in this approach. First of all, it's like 3 levels deep, and also it's quite complex. It's not readable. So this is the only caveat for our features with callback OMS. So in the next video, we'll just try to like have a better design of this code, which looks cleaner than this, by using features with composition OMS. So see you all in the next video.